This assessment asks us to rationalize why the exocyclic hydrogens on the 18-annuline have a chemical shift of 8.9 ppm, while the endocyclic hydrogens of the annuline have a chemical shift of negative 1.8 ppm, especially when those hydrogens look like they should be fairly similar and should have fairly similar chemical shift values. The annuline is an aromatic ring, which means that the conjugated system of the electrons in the ring induce a ring current, and that ring current has some impact on the external magnetic field felt by the endocyclic and exocyclic environments of that ring. If we put this molecule in an NMR spectrometer in some kind of external magnetic field, the ring current reinforces that external magnetic field for the exocyclic hydrogens. That serves to further deshield these exocyclic hydrogens, and when those hydrogens are further deshielded, their chemical shift moves further downfield, and so the exocyclic hydrogens have a deshielded chemical shift of about 8.9 ppm. That same ring current, though, for the endocyclic hydrogens, the ring current ends up opposing the magnetic field for those endocyclic hydrogens. And because it opposes that external magnetic field, that serves to further shield those hydrogens, so much so that the chemical shift of those endocyclic hydrogens is in the negative region. It's negative 1.8 ppm. So that ring current of the aromatic ring system causes the exocyclic hydrogens to be further deshielded and the endocyclic hydrogens to be much further shielded than we would otherwise expect.